Hello students. So let us continue with chapter 11, work and energy. We have finished in the previous video the derivation for potential energy. Now we'll not continue with the theory. First we'll continue with the box questions or colored questions given in between the topics and the solved sums. In the sixth video, we were doing the questions given on the page number 149. We did two questions. Now let us see the third question. Third question is define 1 joule of work. So you have to define 1 joule. Work done, you know W is F into S. So work done is said to be 1 joule when 1 Newton of force acting on a body displaces it by 1 meter in the direction of force applied. Because W is F into S, W will be 1 joule when F is 1 Newton and S is 1 meter, that too in the direction of force applied. Now let me read the fourth question. Fourth question is, a pair of bullocks exerts a force of 140 Newton on a plough. The field being ploughed is 15 meter long. How much work is done in ploughing the length of the field? I read the question again and we should write now what is given. So, a pair of bullocks exert a force of 140 Newton on a plough. So, what is given? Force, capital F is 140 Newtons. Okay. The field being ploughed is 15 meter long. So, length of the field that is ploughed is S is 15 meter. It means this is the displacement covered by the plough. So a pair of bullocks cart is exerting force, exerting a force of this 140 Newton on a plough. It means plough has been displaced through 15 meter. S is 15 meter as this is the length of the field that has been ploughed. So how much work is done in ploughing the length of this field? Work done W you have to find out. Everything is in the SI system, so no conversion required, and W is F into S. As we know, force exerted by plough and the displacement produced will be in the same direction. So just put the value of F and S, we get W is equal to 2100 joules. Okay, if you don't write the unit, you will lose marks. With this, we have finished the questions given on page number 149. Now let us continue. Now let us see example 11.3. An object of mass 15 kg is moving with the uniform velocity of 4 meter per second. What is the kinetic energy possessed by the object? An object of mass 15 kg is moving with a uniform velocity of 4 meter per second. So, given mass m is 15 kg and velocity is 4 meter per second. Since I have read the question now, so I know that there is only one velocity, no initial final velocity, then I can denote it by small b. You are supposed to find the kinetic energy, which you can write k dot e dot or the full name, or we can write simply capital E or EK for kinetic energy. So this we have to find out. This is having SI unit, so no conversion required. Kinetic energy formula we know is half mv square. So first write the formula. If you put the values directly for this EK, you will lose marks. First write the formula, then put the values. Remember it is v square, 4 square. So 4 into 4, do the simplification and your answer comes out to be 120 joules. So kinetic energy is 120 joules. This was a very straightforward numerical, no conversion required and no complications. Just use a formula, put the values and get the answer. Example 11.4 now. What is the work to be done to increase the velocity of a car from 30 km per hour to 60 km per hour if the mass of the car is 1500 kg? So question is, what is the work to be done? You have to find out work. W is equal to question mark. To increase the velocity of a car from 30 km per hour to 60 km per hour, it means initial velocity given is u is 30 km per hour and v is 60 km per hour. If mass of the car is 1500 kg, so small m, mass of the car is 1500 kg. You have to find out the work done to increase the velocity of a car from 30 to 60 km per hour. Now in this case, as you know that for work done, we have seen only one formula. That is W is F into S into cos theta, and according to your syllabus, mostly when theta is 0, W is F into S. But in this case, there is no F given and no S given because F is equal to MA. Even if we try to use that formula, F is given but A is not given, and since time is not given, we cannot find even A. Otherwise, A is V minus U upon T. So in this case, using W as F into S, you cannot find out the work done as things are not given. Okay, so you have to find work, but before that, just to see if any conversion is required. This kg is SI unit, but it is kilometer per hour for the two speeds or magnitude of velocities. So we have to convert them into meter per second first by multiplying each of them by 5 by 80. Okay, so we have got U is 30 km per hour is equal to 25 by 3 meter per second and V is 60 km per hour, that is 50 by 3 meter per second. So how we'll do this? How we'll find the work done as F and S both are not given and we cannot find out also from these given things. We will use the work energy theorem or work energy principle, according to which work done on a body is equal to change in its mechanical energy, and in this case nothing is mentioned about potential energy or nothing is mentioned about the change in position of height. Okay, so we can write work done is equal to, because in this case mechanical energy is only kinetic energy, so work done is actually change in kinetic energy, that is final kinetic energy minus initial kinetic energy. And you know the formula for kinetic energy is half mv square. When v is the speed, it is half mv square. So final kinetic energy is half mv square minus initial kinetic energy will be half mu square. Either you can put these values and find half mv square and half mu square, that is final and initial kinetic energy separately, and then subtract them to get the work done. Or you can do the way I have done. What I did, I have not found them separately. I have written here the formula and then I have taken half m common out. In the bracket v square minus u square. So we can write this v square minus u square as v minus u into v plus u. Okay. And then I have put the values because it becomes simpler. Half into mass 1500 into v minus u. So 50 by 3 minus 25 by 3 into v plus u, 50 by 3 plus 25 by 3. Okay, since the denominator is same for both the numbers, so the calculations are very simple here. And when you do the calculations, final answer comes out to be 156,250 joules. That is 1,56,250 joules. So remember students, so whenever W is F into S, you cannot use this formula. The other method is you can just write work done is change in mechanical energy of a body. The mechanical energy mostly for your case in 9th class will be either kinetic or potential. You will not be having the combination of both the energies present in a body. Okay, I hope it's clear. Example 11.5. Find the energy possessed by an object of mass 10 kg when it is at a height of 6 meters above the ground. Given small g is 9.8 meter per second square. Find the energy, so I'll read it again. Find the energy possessed by an object of mass 10 kg when it is at a height of 6 meter above the ground. So what is Mass small m is 10 kg and height at which the body lies above the ground, that is small h, is 6 meters. Given small g is 9.8 meter per second square. You have to find energy of this body. So as the energy is lying at some height above the ground, we know the energy is potential energy. You can simply write energy, or I have written here P dot E dot, that is potential energy, represented by EP. You can use simple capital E also. So here you know the formula, capital EP is mgh and everything is in SI system of units only. So m is 10 kg into g is 9.8 meter per second square and h is 6 meters. So when you put the values, you multiply them, you get the answer for potential energy as 588 joules. I hope this is also a very simple numerical where no conversion required. Just use the formula, put the values and get the answer. Now example 11.6. An object of mass 12 kg is at a certain height above the ground. If the potential energy of the object is 480 joules, find the height at which the object is with respect to the ground. Given small g is 10 meter per second square. So here in this example, it is given that an object of mass 12 kg, so m is 12 kg, is at a certain height above the ground. So if the potential energy is 480 joules, EP stands for potential energy, it is 480 joules, then find the height at which the object is with respect to the ground. You have to find out the height, which we represent by small h, given that small g is 10 meter per second square. So in order to find this, what you will do, you will simply use a potential energy formula. EP is mgh. There is no conversion required because all quantities are having SI units. So EP is mgh. Just put the values, as you don't have h in this, everything else is known to you. So 480 is 12 into 10 into h. You can cancel 0 here, or you can simplify like this. H is 480 divided by 12 into 10 is 120, and you get the answer of height h as 4 meters. So with this we have solved the examples. Till 11.6 we have solved all the examples, and the box questions we have done. We will be continuing with the box questions given after the energy topic in our next video. Thank you, students.